Fantastic. Hello, everybody. My name is Jack, as Natasha already introduced. I'm from HelmGuard AI. And today I'm going to show you how we're bringing some of these Agent Studio features into production at HelmGuard. So the agenda for today is as follows. Firstly, I'm just going to start off talking a bit about our startup and what we do, our mission, and how we're using Agent Studio. Then I'm going to go on and talk about the reason why we chose to use Palantir as a startup. Typically it's been seen as a bit of an enterprise platform, but I think it actually has some really nice properties for startups. Then I'm going to show you a demo of the tech. I'm going to hand it back over to Natasha to talk about what it takes to build an AI agent in production. Then we're going to go under the hood, have a look at a little bit of the back-end coding using some of the features that Natasha just introduced. Then we're going to talk about evals, how we've actually improved the system using the eval suite in prod. And then we're going to have a bit of a reflection, a bit of a Q&A. I'm sure there are going to be many, many questions about how we've done things. Okay, cool. So yeah, just a little bit about us at HelmGuard. So we're a very, very new startup founded in the fall last year. And we're basically set up with the following core mission. We see that AI models are providing incredible value to enterprise, but they're also supercharging security threat actors, especially with some of those sort of open source models that have been coming out. It enables people to use AI in order to increase the level of cybersecurity threat. And we think what you really need to do is increase the defensive capabilities of AI models. And so what we're doing is we're trying to automate such workflows in compliance and security to really uplift defense. And so our differentiation comes around the use of advanced AI, the way we're representing knowledge inside of Palantir and the ontology, and then just understanding unstructured data processing and the actual workflows that we see in the enterprise. Fantastic. So just a bit about why we chose Palantir. It seems a bit of a weird choice as a startup, but actually we think that Palantir has saved us maybe 6 months to 12 months of development time. And as a startup, you want to move really, really quickly to find product market fit as soon as humanly possible. And so we thought we wanted to spend all of our time doing that. We didn't want to have to answer as many questions about our own security as a security startup. We wanted to leverage Palantir security. We didn't want to have to set up things around reflections, evals, logic, automation, all of that stuff. We didn't want to have to come up with our own SDK. And luckily, Palantir has all of this stuff so that we can get down to focusing what really matters, finding customer pain as soon as humanly possible. And in the workflow that I'm going to talk today about, the workflow is in third-party risk management. So the problem statement is as follows. I am a company, I'm selling to another company, and I've received a security questionnaire. Now, these security questionnaires are really long, really boring to fill out, and there are basically 3 points of pain that we solve in this process. The first is we automatically answer the questions from these questionnaires. This is done via logic, a few automation functions. We have some judge LLMs that help us understand whether it's been answered well by our AI agents. Then we automatically send off questions that aren't resolved to the relevant party internally that needs to answer the questions. And then third, we review the answers and then send it back to the customer. So usually one of these questionnaires can take about a month. I actually know the person at Palantir that runs these things, and it's a massive pain. But actually, we found in previous deployments, we've been able to take down time by 90% in these kinds of workflows. So let me just move over now to the demo, and I can show you how things are working. So here we have CloudGuard Defense, a company that is set up on the platform that provides secure cloud infrastructure and zero trust networking solutions. And here we can see some questionnaires that have been received by CloudGuard Defense. One is from Yara Ventures, and the other one is from Notable Tech Inc. So the Yara Ventures questionnaire hasn't yet been done by our system. So we can see here an example of one of these questionnaires. This is actually a notionalized example from one of the questionnaires that we've seen in real life. And typically what you would do is have this in Excel. You would look at your question bank and you would say, okay, I've received this question before. Is there a formal process for security governance? And then a human would basically interpolate between the questions and answers already provided, maybe look at some unstructured documentation and come to an answer. What we do at HelmGuard is do this for you. So we provide the answer using an LLM. Then we get another LLM to judge the answer using some of the citation tricks that we saw before. And then finally, we actually allocate the question and answer, if it hasn't already been provided, to a particular internal team that is best at answering this. It might be the cloud security team, it might be the legal team, it might be the risk team or the governance team. And as you can see, there's like sort of reasoning provided for each one of these answers, and so on and so forth. So once I have gotten these answers, I can then send for review, and it will send the questions that haven't been answered already to the relevant teams internally. So if I go to this Cloud Security Department view of the questions and answers, I can start a chat interface with Helm, sort of our AI agent that's managing this process. And this is run through OSDK, which is calling Agent Studio in the background. And if this works, we can see that Helm is certainly happy to help us in our journey of answering this question that's been received from a customer. And so we can see here that it said, OK, is Zero Trust networking implemented across all cloud environments? And I hope you can see that all right. And the first thing we're going to do is we're going to say, OK, on file, the AI has seen there's no standard exact policy for this in the unstructured documentation. But I in cloud security know that this is the case. So the first thing I'm going to do is say, can you get the relevant information on file about what is currently noted down? And what this will do, somebody before talked about custom chunking strategies. We've actually brought in a custom chunking strategy for some of these policies, where you can see the semantic chunks that we've pulled out here. We do this through sort of a proprietary method to get out the relevant chunks for security. What this is doing is in the background, and you'll see this in a little bit, calling a tool to get that information, doing some function back context and so on and so forth. And so we can see, OK, right now in our standards and policies, what is on file regarding this question? And then I can then work with the LLM to then finally come to a solution to the problem. OK, great. So that's just a little demo about how we're solving this very specific pain point. As I said before, I think we can take down processing times for this by 90%, with human interaction only coming in the most necessary components. But I'll put it back to the PowerPoint now and hand it over to Natasha to talk a little bit more.
So Jack showed basically an agentic workflow in production here. And if we want to start to think about what does it take to actually build these agentic workflows, you need a source of truth for your LLMs. You need a source of information and a knowledge base for them to reference. At Palantir, that is the ontology. We've spent over a decade actually helping our customers get their data in the place where they can build operational workflows on top of them, and now AI workflows. You also need to give your agent the context that's right for the task at hand. Jack's doing this in his demo with function-backed retrieval context, and he'll show actually how he does that under the hood in a second. And you also need for your agent to have the ability to take action and reason. Maybe you need to get more context from your documentation, or you actually want to open, resolve, edit tickets. And Jack is also doing both of those things. And so I'll hand it back over to him to show under the hood.
Cool, fantastic. Thanks, Natasha. Unfortunately, I was quite sad to say that JPAL is not going to arrive in this particular demo. I quite liked the video demonstration before, but I'm just going to go through, as Natasha was saying before, those 3 points. So how are we encoding this knowledge in the ontology? How are we allowing the agent to get the right context at the right time? And then thirdly, how are we giving it the actions to then write back to that ontology and do useful work? I think one thing that I think about a lot when building these sort of AI agents is what does it look like from the AI agent's perspective? You want to abstract as much as possible away any complexity for the agent. So it's just seeing exactly what it needs to know in order to help the user in the most effective way possible. So let's have a little look at how we're doing the construction of sort of the ontology here. So we have the notion of an allocatable group. So before, this was the cloud security department that needed to answer 1 or 2 questions that was allocated by the AI. We have the notion of a questionnaire, which is a set of questions. We have the notion of a question, and we have the notion of an answer. And what you were seeing before in the big table was basically logic functions, automates written across these 4 objects as they get received into the platform, as the user modifies them, so on and so forth. So that's how we're building out our ontology. Then next is the function-backed context that Natasha was talking about before. So I have it up here. I think it might be a little bit too small for people to see. But this is a new feature that's recently come out on the platform. And basically, as I said before, if we want to think about the abstraction of the agent, all the agent wants to know is what is the next question that I need to help the user answer. And we want to abstract out any logic concerned with coming up with that question. So here we write a TypeScript function that looks through all of the questions, look through all of the answers, look through the status, has it been answered satisfactorily or not. Basically, we do a bunch of filtering, so on and so forth, and then we return back the question that is next needing to be answered by this particular allocatable group for this particular questionnaire, and we return it to the agent itself. Then we actually expose an action, which is to update the status and the answer to the question. So the agent, after deliberating with the user, can come back and say, great, here's the new answer to the question, and it goes back into the source of truth. So now what I'd love to do is just have a little look at what is going on under the hood as we had that conversation before. So what I'm going to do is simply copy and paste in what I said before back into the agent. So here I've got the questionnaire agent, and we can see what reasoning is happening under the hood inside of AIP logic. And now I could have maybe implemented this in a month's time of the guardrails, the reflection, so on and so forth. But with Palantir, it just came out of the box. So what we're seeing here is the first thing that happens after every single message is we're using that function before to get the next question that needs to be answered. So the questionnaire ID goes in, the allocatable group ID comes in, and we can see the question that comes out. Is zero trust networking implemented across? Then we see the sort of agent thinking about it, so on and so forth. And so then I say, okay, great. What do we have on file about this particular policy? Then we'll see the reasoning again. The function back context occurs again because it occurs at the start of every question. Then we'll see that the agent actually decides to use the tool query semantic chunks of a client. This is written inside of logic. So as somebody was saying before, you can actually just write the function as logic. You can write the function in TypeScript. It doesn't really matter on the platform. And we can see how it's taken in the chunks that we had before that I showed you previously and written a summary. And then if we continued, we would then be able to take the action to then write that back down. And you can see the actual functions that it has access to here. One is query, one is update answer, and the other one is the function back context. But yeah, I'll just move back over to the slides and let Natasha talk about bringing this sort of stuff into production.
Great. As Jack showed, his agent is actually relatively simple now that he has the full power of AIP. I mean, it has one retrieval context function, and then it has two tools that it can use. And so once we have the building blocks for creating agents, if we are thinking about deploying them into production, there's kind of 2 key things that you want. One is evaluations, and the other is the ability for the agent to improve over time and to establish feedback loops. So for evaluations, it's as you change your model, if you upgrade to the latest model, you need to know that that is actually not degrading your system in any way or degrading performance. And for feedback loops, as your agent is learning over time and as you're learning more about the workflow, how does your agent actually improve? Jack's going to actually show how he's doing that at HelmGuard.
Cool, fantastic. So if we just jump back to the demo on the laptop, we can see an eval suite. So this is taking advantage of what Natasha was just saying, publishing this function, this agent as a function. And so now that this agent is a function, it can go back into the plethora of other components available on the Palantir platform. And one of those components is evals. So what I didn't show before is the way in which we're constructing the prompt for this particular model. So I'm using Claude here for backing this particular agent, and we can see the way in which we're constructing the prompt. Basically, we give it the goal and basically describe, okay, in the context window, you're going to receive a questionnaire, you're going to receive a question ID, a question text, so on and so forth. Other relevant context is going to exist inside of the application state variables. So these are basically IDs that the agent can use in order to call functions. And then we basically say you have access to two tools. The first one is like querying the semantic chunks that we've produced before on the ontology. And the other one is updating an answer to the relevant question. And we can see that there's been like a few sort of additional notes and indeed one a sort of all capital letter instruction to the agent to stop it from doing particular things. And so you might ask, okay, you have these additional notes. How did I actually construct this agent from the ground up and get the reliability to put it in prod? So the way I usually sort of construct these prompts is I'll start out with something like this. So if you can see there, this would be the sort of naive prompt that you would start with. Okay, you know, you're an agent doing this. Before each message, you're going to get this, and you have access to these two tools. Then you might start going back and forth with the agent. You might try it out in like an ecologically valid scenario. You know, internally, you're going to be talking sort of back and forth. But another way to do that is to be really sort of careful about the evaluations that you're putting into things, right? So thinking from the ground up, as you would in regular software development, what are the edge cases of the system? Where is it going to go wrong? What are the expected behaviors? So on and so forth. And so what we did was, and this is not the full testing suite from before, but what we did was encoded some of the assumptions we had about the paradigm into this evaluation suite. And then we created judge LLM functions in order to review the answers. So a good one is we noticed that like there was a bit of an unintuitive thing happening at the start of conversations where the agent really wouldn't introduce itself, it wouldn't introduce its function. And to somebody in the cloud security department that doesn't know about the setup, they just receive a chat link. Who knows what's going to happen? So when we were testing it out, we realized that this was an important thing. So we told the model to introduce itself at the start of every message, and then we wrote a particular test in order to make that happen. Similarly, we noticed through evaluations that the model was a bit too it was too quickly updating the answer before the user had confirmed that the update they wanted to see was going to occur. So then we found that in eval, and then we put this in, and we went from there. And I think one thing that's really interesting about the way that in which these evals are constructed is actually we can use LLMs as a judge, which is a very sort of popular, sort of thing in the literature. So if I go to my platform, go into here, and then if I go to logic functions, and then eval functions, I can actually see that I've written these two eval functions inside of logic. So I think what's really interesting here is like, if you have a member of your team that's looking at this interaction and they're not particularly technical, you can actually get them to use a no-code solution in order to write an LLM as judge evaluation of the outcomes. And so I think this brings LLM development from the place of I'm a Python developer, I'm building up my RAG pipeline, so on and so forth, into a place where actually you don't need to know how to code to do this. And you can just spend all of your time thinking about the interaction that really matters with the user and the actual pain point involved, which I think is really interesting. So I hope that makes sense, and the way in which we improve things over time by basically running these evals, considering the edge cases, sending it out to a user. You know, one of the things we found were like PDF documents after sending out to users were like really, really weird for this kind of use case, so on and so forth. And then basically we iterate on this prompt over here, which is quite interesting. So I'm gonna like leave it here for the demo, and then we're gonna move to a reflection about what we've shown.
So you might not have questionnaires, you might not have the Federal Reserve videos, but you probably actually have something similar. And so when you look at the building blocks of what it takes to create agents for the ontology, instead of questionnaires, maybe you have a ticketing system and a set of tickets. For the ability to give the agent task-specific context, maybe you don't have a question in a questionnaire, as Jack did, but you have a ticket in that ticketing system. And then for the agent to actually run actions and get more context. Maybe you have training documentation. Maybe you have the agent give it the ability to resolve or open or edit your tickets. And so there's actually a lot of generalizable concepts here in the two examples that we showed today.